So let's give that one another shot. Here's one. Why don't you guys press pause and then work on this for a little bit. And if you guys are looking back at, for example, all this work that I've been doing in the calculator with the logarithms, if you do not have a TI Inspire and can't specify the base, go back to my video on the change of base formula, which I believe was learning target 9. If I put that one up there, I might have kind of lumped that into learning target 10, or not 10, but learning target 8. But I do cover change of base formula in there. So here what we're going to do is we're going to again make this into a logarithmic equation. Log base 7 of the number 11 to the x is equal to the exponent on the 7, x minus 1. And same thing, I notice I've got this, this pesky x in the exponent, but now I have a tool to get that out. So we'll make it x times log base 7 of 11 is equal to x minus 1. And back to the calculator again to do log base 7 of 11. And that gets me 1.23. So we'll make this 1.23 times x is equal to x minus 1. And then we'll just continue to solve this. Whoa, that's weird. I don't know what happened. Yeah, I'm getting a weird blue shade. Okay, there it went away. So we'll go ahead and subtract x. And I'll get 0.23x, because that's 1.23 take away 1, is equal to negative 1. And then my last step, I'll just divide both sides by 0.23. And I'll get x is approximately equal to, back here, we'll say 1 divided by 0.23. That's 4.35, and don't forget to tack the negative on there. So x is approximately equal to negative 4.35. Okay? And we've got just one more to look at, which is probably the most advanced one that we'll look at in terms of exponential equations. And here I don't have common bases, and now I've got binomials in both exponents, but we can handle this one. Let's do the same thing. It's going to be logarithmic again. Okay, log base 4 of 10 to the x plus 5 is equal to the exponent on the 4, which was x minus 1. And again, this is a little bit more difficult of an exponent to work with, but we can still bring it out front. And we just have to be careful to make sure that we say this is x plus 5, the whole thing, times log base 4 of 10 equal to x minus 1. And let's figure out what log base 4 of 10 is. We'll go back here and calculate log base 4 of 10. And we got 1.66. Okay? So going back here, we're going to say that we've got 1.66 times the binomial x plus 5. And I'm writing that coefficient out front again and not at the end of the binomial set of parentheses. And that's equal to x minus 1. So now if you notice, it looks like I've got another step to do. This is still, from this point on, like an advanced equation maybe, but it's something that we can definitely do. And I'll have to distribute this 1.66. So it'll be 1.66x plus whatever 5 times 1.66 is. So 5 times 1.66 gets me 8.3. Okay? So that's plus 8.3 is equal to x minus 1. So now this does leave me with another step, but still not too bad. We're going to subtract 8.3 from both sides, and at the same time I'll take away an x. Okay, so that leaves me with 0.66x is equal to negative 1 minus 8.3 is negative 9.3. And then we'll just go ahead and solve by dividing by 0.66. And we get x is equal to, or I should say approximately equal to, once I get this. Did I do that on the last problem, or did I say equal to? Well, let's just figure this one out first. Let's say negative 9.3 divided by 0.66, and we get negative 14.09. Okay, so this is approximately negative 14.09 right there. And so definitely this one was a little bit tougher to look at or to work with, but it's the same exact steps as before. The only place where that deviates from before is when I get to this spot right here, got to use the stars, to that spot right there when I have to now distribute because I'm working with a binomial. Okay, and really quick, let's go back to the last one. No, I did put approximately equal to. Okay, I thought I was losing my mind. Maybe I still am losing my mind, but I just forgot where I lost it. So, yeah, we want to make sure that we understand how to take variables out of the exponents and turn it into an equation that we can solve and work with.